Hello there and welcome back to this video series on control systems. In the last video, we have seen the need for simulation and what we mean by time response analysis. And in that process, we described what are the test signals that we are going to use. In the present video, we'll try to describe the response of the first order system to unit impulse input, unit step input, and unit ramp input. I would strongly encourage you to watch these videos 007 to 011 which describe Laplace transform and how to use Laplace transforms, and video 31 which describes time response analysis. Unless you are thorough with Laplace transforms, it would be very difficult to go through some of the topics. Carefully take notes while you are watching these videos and this video. Keep them handy, solve all the problems mentioned therein to make the most out of this video. With that, we'll begin studying first order system. A first order system has the transfer function Cs over Rs. Cs is the Laplace transform of the output. Rs is the Laplace transform of the input, and this transfer function is 1 over 1 plus tau s. So we take this Rs onto the other side and say Cs is equal to 1 over 1 plus tau s Rs. For each of the test signals, the output is computed to know the behavior of the system. That is, for unit impulse input, substitute Rs and compute what is C of t, okay, time domain function. Similarly, we do it for step input, then ramp input. For our purposes, we will stop there, impulse, step and ramp. We will begin doing that by considering impulse input. For unit impulse function, we have already seen Rs, which is the Laplace transform of unit impulse input, is equal to 1. So we write the output C of s is transfer function multiplied by the input, which comes out to 1 over 1 plus tau s. We slightly modify this because we have the inverse transform of 1 by s plus alpha ready. Okay. So we see that by taking inverse Laplace transform, we get the response of the system to impulse input. We'll try to plot this response 1 over tau e power minus t over tau and see what happens. Obviously, we can see that as this t tends to infinity, this whole response goes down because e power, a very large negative number, tends to 0. We can see that in the plot given here. Along x-axis we have time in terms of 1 time constant, 2 time constants, 3 time constants, and so on. And this is the response of the system. You can see that at 1 time constant tau, it will be at 0.367 by tau. At 2 time constants, it is 0.135 over tau, and then it gradually approaches exponentially the x-axis. So you can see it is starting on y-axis here, and gradually it is coming down to 0. Thus, we see that a first order system is defined or described by one parameter tau. This tau is called the time constant of the first order system. The next input that we are going to see is a step input. We have seen that the Laplace transform of a step input is given to be 1 over s. Therefore, we say the Laplace transform of the output is 1 over 1 plus tau s. This is the transfer function of first order system, multiplied by 1 over s, which is the Laplace transform of the input. We can split this by using partial fractions method to obtain the Laplace transform of the output given over here. So C of t is evaluated to be 1 minus e power minus t over tau. At once we can see that this term e over minus t by tau goes to 0 as time t increases. So in the limit C of t approaches 1. We will show this C of t response on a plot here. Okay. In this plot, time is plotted along x-axis in terms of the time constant. After 1 time constant, 2 time constants, and so on. And on y-axis, we show both output as well as the input. Input is staying constant at 1, whereas the output is rising. Okay. How it rises, we have shown in the table here, and also we'll show on the graph. At 1 time constant, it is 0.632, that is 63.2% of the input. Then at time 2 tau, it is 86.5% of the input. Similarly, at time constant 3 tau, it is at 95% of the input. And at time 4 tau, it is 98.2% of the input. These two are very important because they are called, this 3 tau time instant is called 5% settling input, because 100 minus 95% is 5. Here it is 98%, so this 4 tau is called 2% settling time. We need to remember these two. For a first order system, 5% settling time is 3 tau, 2% settling time is 4 tau. Okay. If it goes to 5 tau, 6 tau, this CT graph comes closer and closer to the unit input value given there. We may notice that as time t tends to infinity, CT tends to 1. And we say that the first order system tracks the step input. We use the subscript SS to indicate the steady state value. Steady state value for the RAM input, response of the system to ramp input is 1. We noted that 5% settling time is 3 tau, 2% settling time is 4 tau. We can see one feature of LTI systems. This 1 minus e power minus t over tau is the response of the system to step input. If you differentiate it, you will get impulse response. So derivative of step response is impulse response. We perform a similar analysis for amp input, noting that its Laplace transform is 1 over s square. We write C of s, split it into partial fractions, and note that C of t comes out to be this. We define error E of t is the difference between input and output. That comes out to be tau minus tau e power minus t over tau. This term goes to 0, whereas this term remains. That is, some error remains, and that is why we say that a first order system cannot track a ramp input. This plot shows the response of a first order system to a unit ramp input. Okay, this red line shows the input and this blue line shows the output. Okay, you can see that there is a difference of 1 time constant along the time axis and 1 time constant along the output axis. Okay, so this output lags by a time lags by 1 time constant, and that is what we say here. We say that the first order system cannot track ramp input. Also notice, if you differentiate the ramp response, you get the step response. This is one feature of linear time invariant systems. You take the ramp input, differentiate, you get step input. That you differentiate, you get impulse input. The same applies to output also. Take ramp response, differentiate, you get step response. Differentiate and you get impulse response. With that, we'll summarize the present video. We studied the response of first order system when subjected to unit impulse input, unit step input, and unit ramp input. It is seen that the first order system can track the step input but cannot track the ramp input. There is a steady state error present. That's all for now. Have a great day.